So I think there's two common mistakes that I see being made in the development in the automotive industry. And here, maybe the automotive industry still has some opportunity to learn from other industries like aerospace, like nuclear, like railway, that have a maybe more entrenched, stronger safety culture over many more decades than the automotive industry has. But the two common mistakes that I see is first a thinking, okay, now we need to add safety, so what do we add? And normally adding things is not good for safety. Simple is always good for safety, because safety is about reasoning and arguing and understanding the failure modes and conditions the system can get into. So if you find yourself in that mode of thinking, what do we now add for safety? There's a big risk that you might be just heading down the wrong path. The second thing that I see very often is the safety standards like ISO 26262. They prescribe a process to follow for the development of the software. And if you're not careful, that becomes the goal of the development process, to get MCDC coverage of the code. Now, actually, the guidelines or the reasons those things exist in the safety standards are to check that your tests are good quality. So the goal isn't to get safety coverage. The goal is to test the functionality of your software is working correctly, and then to see if your tests are good because they cover the code.
What we're also often seeing in a common mistake is that, especially when you run in task force mode, right? So you're at the end of the SOP, and now you need to do everything together. You need to do the development, you need to integrate and test and stuff. And then typically what often an activity is, I document later, right? I now do the code, and then I document when I have more time, right? Often a common mistake is that you don't have time, right? And at the end, you run out without a documentation at the end. And this is also a common mistake. Focus on documentation because it's pretty crucial.
I find it actually a good habit to start the documentation before doing the implementation usually. And that's what in many projects we've been seeing with other groups also that are implementing these kind of habits as a crucial settlement in the teams. Just like with documentation and with some of the other aspects, what we've said already, testing is not something that you can postpone to a later point in time in the project. You shouldn't be addressing it. And we've seen it so often. Yeah, it's like people are thinking of, let me just do that implementation now and I will do the test later, or somebody else can do the tests for me. And it's actually, I would consider that developers need to address a big amount of their actual work into testing and put testing to a very high priority and importance in this concern also. Because exactly this is the case when you postpone that or neglect it in this case, then you will see all these failures introduced into your software designs, into your current architectures, only rising up later on in the project. And then you'll have to change your architecture again and change your implementations overly again. And this is really something hard to address when you come back to a thing that you've implemented 6 months ago to say, like, I need to change that and understand that now. And this is really one of the biggest problems I'd consider in insufficient testing also. Then there's so many disciplines around testing, starting from unit and module testing, going to then integration testing, cybersecurity testing, and vulnerabilities and so on. So this is really something that should be addressed from minute one, starting directly with your processes, starting with an engineering process that introduces and integrates your testing capabilities and abilities directly, making it a test-driven design.
What we're also seeing quite often, right, is that a lot of tests are only to test against a specific specification, right? So you test the compatibility to APIs, you test compatibility of components to the specification. But what is also quite important is to make sure to test against irregular use of the software components. We call this more or less fuzzing, right? So here, more or less, you try to generate test cases also based on random data and test and check how the component, the ECU or the software component, is behaving after providing random test data, especially when then you cause that the ECU is rebooting or stuff like that, or suddenly in an interrupt mode. You test and validate then what behaves then, what is the measures you're seeing then, and then you try to equip again the device with additional test cases, for example. And this is quite important to also make sure that you're not only testing in the specification, because also, as said already, but also make sure that you are also making sure that you are testing against irregular use of the component.